Hello, this week we're going to be talking about hypotheses, your research hypotheses, and developing them as part of Chapter 1. You're going to be working this week on the hypotheses and definitions of your research variables, and these will both be after your statement of the problem and purpose of the study. So we continue to narrow down from a general problem to the purpose of the study, and now what questions are you going to answer? So a hypothesis is a prediction based on theory, intuition, evidence from previous research, or questions left unanswered in previous research, previous literature. So you guys have had ideas about what you think is a question you want to research, and now we're going to make a prediction about what you think is going to happen as a result of what you're going to do in your classroom or library. So you are going to predict something. If I do this, if I do X, Y is going to happen. And it's also it could be either that or a statement of relationship between two variables you're investigating. If X happens, if X is this, then Y is that. I'm going to explain more. But basically, it's an answer to your research question. What is the question, your purpose of your study, your research question? You're going to predict it with the research hypothesis. One of the things you need to keep in mind before you can answer the general question is you need to define in your own mind what variables you'll be focusing on and define them in terms of your study. So how will you define your variables in operational or measurable terms? So it's called operationalizing your hypothesis. It's a way of taking your ideas and putting them in a measurable format. Your hypothesis, in order to support, and we're not going to ever say that you're going to prove your hypothesis. You can't prove your hypothesis, you can only support your prediction. If you notice when you're reading your studies, they won't say that they've proved something, they'll say they supported their prediction. And that they found it to be supported statistically or some other way that they've found it to be supported. But you need to test it to see if you can say that your hypothesis is supported by the data you've collected. So it has to be related. What you do in your classroom study has to be related to the variables of your hypothesis and to be directed at answering the question behind your prediction. So if I'm going to try and measure, think of it in terms of diet, that eating fewer calories leads to weight loss. I have to figure out what my measurables are going to be. And that's really obvious in this case because it's going to be calories and weight. So what's the relationship between reduced calories and reduced weight? I'm going to predict that if I eat fewer calories, I'm going to weigh less, and therefore I can operationalize that by counting calories and by weighing myself. Rather, you wouldn't necessarily want to, even though a good personal way might be to see how your clothes fit, that's probably not going to be a great way to measure it in terms of a study. So weighing myself on a scale will work for testing the hypothesis. So how do you formulate a testable hypothesis? It's not an easy thing to do. So if you get frustrated writing this, that's perfectly understandable. But what you need to think about is it must contain a prediction about the relationship between two variables. And if you remember, we looked at independent and dependent variables. So if you take an independent variable, which in the case I just gave you was calories, and a dependent variable, weight, we have to see what the relationship is between these two variables. It could be a correlational relationship, such as the more time students spend practicing keyboarding, the longer their written pieces will be. And we have two measurables there. You have time spent practicing keyboarding, and longer written pieces. So you can see that if you want to look at the relationship between keyboarding and writing, we've structured it in terms of things that we can measure in order to test the relationship. Or it can take the form of a prediction about how at least two groups will differ from one another. Students who learn technology skills as tools for completing an ongoing project will achieve greater mastery of those skills than students who learn each skill in an isolated context. That's an example. So in my diet example, we can say that two groups will differ from one another. One group doesn't change their calorie intake or changes it by a small amount. The other group changes it by a larger amount. So how are those two groups going to differ in the outcome, which is weight loss? It's Halloween when I'm recording this. Eating is at the top of my brain. Also, having sat around with a broken arm, eating is at the top of my brain. So formulated, you can also look at how the same group performs differently on two types of instruction. So students' mathematical performance will be better when they use manipulative materials during the learning process than when they do not use manipulatives during the process. So you can see that the same group, you do two different things. So the same group, a group of people reduce calories, another group of people increase exercise. And what is the outcome on these two different interventions? In either formulation, however, in any of these formulations, there are lots of terms that need to be defined before they can be assessed. You might find, so how you define the measurements, how you decide to measure, what are you meaning by improving test scores? What are those test scores going to be? What are manipulatives? What are you using? And these are the things you're going to be defining as you write your hypothesis. What needs to be defined are the words in your hypothesis as they're going to be used in the study at this time. It may be that manipulatives, I wish that wasn't the example because I can't say that word, but manipulatives can mean many different things. What are manipulatives going to be in this particular case in your hypothesis? So what you are measuring also affects the design of your study, and the hypothesis and the design of the study and the measurement all need to work together. So if I'm looking at counting calories and doing exercise, if I'm just looking at counting calories, that's going to be a very different study design than if I'm looking at exercise. And as you write your hypothesis, you can begin to see how the design of the study is going to take place, or what it will entail. And it might mean how you split up your classroom, how you start and stop your study. What kind do you do? Groups? Do you do classrooms? Some people have compared classrooms, especially easy in a library when you have multiple classes coming in, as long as you, and we're going to talk about ethics in another lecture, but you want to not privilege one group over the other. So maybe if 6 weeks you give them an added intervention, you might switch it around, and after your study give the other group, if it proves to be a useful intervention, plan to use that intervention with another group. So you might also need set up some kind of artificial division within your classroom. You can set up different groups that you do different things with. So what you're going to test will certainly reflect the design of your study, how you're going to do it, what the methodology is, and that goes into chapter 3. But certainly they're going to work together. Your hypotheses are generally going to be directional, which means that one group will have higher scores than another group, or the scores on the test will increase, the weight on the scale, number on the scale will go down. So you need to set some kind of most of you will have an expected directional hypothesis. Sometimes you don't have a particular direction in mind. You think that doing something you may think that motivation to tackle, for example, motivation to tackle difficult problems will be affected by using some kind of video technology, but you're not sure if it will increase or decrease. Will using the technology make the kids more active because it's visually stimulating, or will it put them into a passive bystander mode? So in that case, you might not want to make a directional prediction, but only that there will be a difference in motivation, or a difference that could go either way. The one type of hypothesis that you don't want, so we had a directional, going up, going down, getting better, getting worse, or it will make a difference, but you don't know whether it'll be a positive or negative difference. But the one kind of hypothesis that you don't want to have, in other words, you don't want to predict that there will be no difference found. If you are aware of statistics and have heard of a null hypothesis, that's what you posit in a null hypothesis, that there's no difference, and statistically you want to find the difference. But in terms of writing a research hypothesis, you don't want to posit, you don't want to create a hypothesis with no difference. So we'll talk about null hypothesis when we go over some statistical procedures, but that's different than what you want to think about in terms of a research hypothesis where there'll be a difference. You might also think about exploratory hypotheses. You might not know what to expect from a learning situation, and you might want to make the predictions after the fact. And this is a qualitative research model. And some of you have already indicated that you're leaning that way, and we will talk about that. I want you to try and write a hypothesis, a predictive hypothesis, unless you find that you really just can't. We will talk about this because I want to meet with you as you're working through this and after you write this. Some of you might have mixed methods where you have some predictions that will be measured quantitatively through collecting data on test scores or time spent or some other measure. And some of you might have survey data where we'll be doing some kind of grounded methodology. I can't think of the word right now, and have some of both. So as you create your research questions and research hypothesis, we'll decide how you're going to lean. If you're doing both, you may use these exploratory hypotheses in your additional questions. So you may have two or three research hypotheses and then some additional questions that you want to look at that are more exploratory hypotheses that you want to observe and collect information about. One of the things that you need to think about in doing your hypothesis in terms of two variables, two groups, is that you must state some kind of comparison outright. So you need to say better than what or more effective than what. Sometimes it can be a pre and post kind of things. So if you can't just say they perform better, you have to say after the intervention they have a better test score than they did before. So in that case, you'd need to have some kind of level and I'm phrasing this in terms of test scores, although I know some of you will be doing other kinds of interventions than tests. It might be surveys of attitudes or whatever. But you need to have a before survey so that you have something to compare against after, so that you know if things have changed. So you can't just say students will do better at reading. We have to say better at reading than they did before this intervention. You have to compare. That's why comparing two groups is kind of nice, because it's an easy comparison between the results in one group and the results in a group with an intervention. One group without an intervention, another group with an intervention. But it certainly is possible, if you need to do the same thing for every group in the classroom or everyone in the classroom, you can do a before and after type of comparison, and that would work as a hypothesis. So remember that for testability, when you have a hypothesis, you need to state the variables in measurable or operational terms, as we discussed. For example, positive effect is not clear. You can't say, I'm going to do this and we'll have a positive effect. You need to say, it will improve X. This will change. I can measure from one to the other. But positive attitudes, and attitudes can be measured on surveys. So, they'll have a positive change in attitudes from one survey to the next, or they'll have a positive increase in test scores, if that's what you're going to use. It's very hard to come up with examples, but you need to define your variable terms, what you're measuring, in clear, objective, observable, and potentially measurable ways. And that's so that you have a way of proceeding. And we've already talked about this a little bit in our early conversations, and we'll talk about it more after you write your hypothesis. And this measurability and operational terms are going to be parts of chapters 1 and 3, because chapter 1, you're going to write your hypothesis and you're going to write your definitions. In chapter 3, you're going to write your methodology, which comes back to your hypothesis, and how you're going to, what exact things you're going to use in terms of tests, scales, interviews, surveys, etc. Right now, we're just going to be working on chapter 1 and writing the hypothesis, which is enough. So, for example, some hypothesis. It was hypothesized when middle school students played games and learning new mathematics concepts, they would develop a better understanding of the concepts than when they learned the same content without playing games. So you're comparing two groups of middle school students, one who are playing games and one who are not playing games but using the same content. Notice you always write your hypothesis in past tense, and you're going to write chapter 3 in past tense, even though you're writing it before you actually do it. When you read through it, it's already done. So we're planning out. Chapter 3 is going to be your template for what you're doing, but it's going to be read as what you did. And sometimes we need to go back and change what you did in chapter 3 because of things that come up. Middle school students are your who. That's the groups that you're comparing. Games will need to be defined. That's your independent variable. You're giving the games to some students and no games to other students. So games is a word, everybody knows what games are. But in this particular thing, what are the games going to be? Mathematics games on a computer, including X, Y, and Z. So that will be your definition that you need to include in this chapter. Mathematical concepts needs to be defined. And understanding. How are you going to measure their better understanding? Through test scores, through surveys, through their use of them in another context. We have to find out how you're going to measure better understanding. This is actually two groups. So they're going to first play the game, learn the content without playing games, and then the same group is going to learn the content with playing games. I would like that to be clearer in this hypothesis. I don't love this hypothesis. If you were going to use two different groups who played games and learning new mathematical concepts would develop a better understanding than students who learn the same content without playing games. So the difference here is then when they learn the same content, and here it's then students who learn the same content without playing games. I think this is the better way to do this kind of thing. Although I guess you could do a teach the content without the games, some kind of measurement, teach the content with games, additional measurement. And that way you might even do 3 measurements, beginning, what do they know about the content, teach the content without games, take another measurement, teach the content with games, take another measurement, compare the increases in improvement, the better understanding, however you're going to measure that, compare those 2 increases to see whether there was a more increase in without the games or with the games. So this is the kind of thing that when I'm talking about the design of your study, this is what I'm talking about. If you design the study so that you're going to take your same group of students through this process, learn it without the games, learn it with the games, it's going to look very different than if you compare 2 groups of students. How you set up your classroom, how you're going to perform the intervention, what you're going to do. It's going to look very different. As you can see, wordsmithing and when you're developing these hypotheses, it's details are going to be very important in how when we construct these. I don't expect your hypotheses to be perfect the first time out. I want you to do your best, and then we're going to play with them. So what should your hypothesis statement contain? Who? The variables? Think about how you're going to measure those variables. What's the comparison being made between 2 groups or 2 variables? What's the direction of the prediction? As we know here, the directions were both positive, increase. They were going to be better understandings than before, or better understandings with than without. And as we said before, past tense. You should begin with, it was hypothesized that. It sounds very boring, but that is the way you should begin. If you're really stuck because your type of what you've come up with your study doesn't seem to be lending itself to this type of comparison and hypothesis, let's make a chance. Let's meet and talk about this before you write this chapter, this part of chapter 1. I'm going to give you a due date. Don't worry about the due date. I'm just giving it to you as a something to shoot for if you can. If not, then if you need more help and more talk before you start writing it, then obviously we push the due date out. All right, so here's something that works and doesn't work. So develop higher geometric. It was hypothesized that middle school learning disabled students in an inclusive mathematics class would develop higher geometric reasoning levels. So we have to figure out how we're going to measure those higher geometric reasoning levels when learning geometry concepts with manipulative materials than similar students who learned only with symbolic or pictorial materials. So you have 2 groups there that you're comparing the 2 groups. One is getting a manipulative material, one's learning with symbolic or pictorial materials. So that works in terms of a research hypothesis because we have 2 groups we're comparing. We have students and we have measurable things that we can measure, higher geometric reasoning levels, and we have the independent variables, the manipulative materials, and the symbolic or pictorial materials. What doesn't work is when you say it was hypothesized that middle school learning disabled in inclusive mathematics class would develop higher geometric reasoning levels when learning geometry concepts with manipulative materials. That has to be phrased as a before and after if you're using a whole class. So you have to phrase that as then you have to would develop higher geometric reasoning levels than before they started learning geometry concepts with manipulative materials. So one looks at the first one looks at which is the better way to do things, and that's why it's a more useful type of hypothesis. The second one looks at, does this work? And do they develop higher geometric reasoning levels from when they started than when they finished? This I might do in kind of a more step type thing and compare maybe the same group learning first with symbolic and then learning with manipulative, like we talked about with a kind of a double setup. It's a little harder to do because you have a shorter period of time, but you could certainly spend 3 weeks with symbolic and pictorial. None of you are going to be doing, I don't think, this manipulative math, but this course was written by somebody who was a math person, as you can note by all of the examples, as I'm trying to change them, but I can't change them all in one couple semesters. But you could make the second one workable by having a beginning test where they take a baseline, use one type of protocol, see where they're at, and use the other type of protocol. The bad thing about that is that you don't know how much of the first one influences the second one. So it's really nice if you can compare different groups against each other and try and make your groups similar. So you want to have, if you're comparing different groups doing the same thing, you want to have groups that have some sort of similar makeup. You don't want to have all a low-level group compared to a high-level group. You want to have groups that are made up of so that they become more homogeneous to compare to one another. So what you're going to be writing are preliminary hypotheses. They're subject to refinement, to change, to updating, to additional things. It's going to take you and I working together, each of you, to come up with a workable hypothesis based on what you want to study, what you found. And this is why I've emphasized in our earlier conversations, understanding, looking for methods in your literature review. See what's out there, see how things have been measured. It will really help you when you're developing your hypothesis and when you're developing your methodology. So take your best shot when you're writing this. Contact me for help if you want to talk through it before you begin writing it. If you think you have some idea, write it and I'll take a look at it and we'll meet and refine it. And then we may refine it again as you write chapter 3, and you may even refine it again after you collect your data, depending on if something happened that knocked you off how your intended methodology for some reason. And so we might have to go back and even change the hypothesis as you're writing chapter 4. That has happened. It's nice to get it into some kind of good shape by the end of the semester if we can, but it is one of the more difficult things to write. So don't be frustrated. And I should, beginning hopefully next week, beginning November 5th, become available again for conferences, individual conferences. Hopefully things will start to be able to function better. So Good luck with writing your hypothesis, and I look forward to reading them.